Okay, back to this one over here. If this is x, this is supposed to be 25 minus x. If the whole thing is supposed to be 25, this is supposed to be x. I have now an angle here, and I have an expression for, oh really? It keeps happening? I don't know how to deselect that without doing all this. This angle of 75 here, that keeps coming up inside that thing, is adjacent to this side, and this would be the hypotenuse. I can re-express this as, well, I know that's actually 25. I don't know if I need to do this x and 25 minus x business. I know that in the right triangle with the x and the 25, I can use the cosine of 75. And write cosine 75 equals adjacent over hypotenuse. Yeah, that's really what I need to do. The x and the 25 minus x is just for fun later. This would be 25. Oh no, I waited too long again. 25. Okay, great. And I get out the calculator. All right, and so the answer to this will be 25 times the cosine of 75 would give me x, and that is 6.47. Let's go back here. So x is, I'll say this, 25 cosine 75 equals, what did I just say, 6.47? Oh, I'm going to have to look. You're going to make me look. 6.47. Yeah. 0.47. That's not going to bother me. I'm not going to let it bother me. 6.47. I can't really see my decimal points. That bothers me. Big old decimal. Oh, come on. There's a decimal there. There is a decimal there. I promise you that. Oh, can I make it? I don't know. I don't know. I don't want to accidentally. There we go. Ooh, I did it. Can I do it down there? 6.47. Okay. Great. Next question. Given circle D with the measure of fi, let me draw that in. The measure from f to I is, this is the arc here, 67, and that's all the way to f. It's not just e. Find fg. Now it looks like I'm supposed to believe that this is a rectangle, but maybe not. I know these are both diameters. Oh wait, if they're both diameters, I think that is a rectangle. Let's investigate here. All right, so if this is 67, what's the arc from F to G? Well, I'm supposed to believe this is the center because it calls it circle D. The arc from here to here, then, I know just makes 180 with the 67. So let's just subtract 180 minus 67, and I'll get this over here. That would be, oh, do this in my head, 70, 113. Okay. That's degrees. G to H, well, oh yeah, it is, because look, if this is 113, I have a semicircle also from F to H. So if that's 113, this is all 180. This also has to be 67. Oh, that's cute. Okay, and then H to I, again, I have a semicircle from G to I, and part of it's there, the rest of it has to be here, and it's got to make 180 all the way around. Okay, great. So then I'm supposed to find the measure of angle FGI. Well, I already know if this is a angle FGI here, intercepts this arc over here. F to G to I has to be half of 67. Oh, that's not a nice number, is it? Oh, well, we'll just have to deal with it. This is 34 and a half. Oh, if I wait too long, it does that. Okay, 4 and a half. Okay. Is that right? Oh, no, it's 33 and a half. Well, if I erase it, maybe it will go away the way I want it to. Is that all going to go away? Yep. All right, it's supposed to be 33 and a half. Oh, but then I didn't get my decimal time. Okay, good. 33 and a half degrees. 33 and a half. And IFH, I to F to H, that intercepts this 113 degree angle down here. Half of 113 is 56 and a half. Great, this is half of the arc it intercepts. Great. Okay, I wanted him to get to the point where we were talking about how the fact that these have to be right angles because there is a diameter here. Silly at the beginning, I didn't realize that. Yeah, this is a diameter, so the point on the circle that connects to endpoints of a diameter is going to have to be a right angle. This connects to the ends of the diameter FH, etc., etc. I missed the one because it was being cranky. Anyway, that's definitely a rectangle. Okay. Given circle A with the arc from C to K, that's right here, this is 53. The arc from G to E, that's from here to here, is 101. That's a little weird because it goes all the way around point F. G to E is 101. G to F is 31. Well, thank you very much. You know what? Before I lose any sleep over it, I'm going to say, well, that must be 70. You can just subtract those. And I haven't even read all the givens yet. And DCA is 90. Well, when they say DCA, they didn't even draw in CA here. DCA is 90. That really just tells me that this is tangent. Cross my T this time? Oh, nice. That is a tangent. Okay, but it's not tangent. It's not a right angle like this because it's a right angle to A. Okay, GIE is the first thing I'm looking for. G to I to E. All right, that's one of those bow ties where we get these two angles. These are either one of those is the average of the arc's intercepts. Otherwise, I have to add 101 plus 53 and divide by 2. Can I do this here? Do I have enough room? 101 plus 53. Oh, I think I took too much time. Divided by 2. Ah, worked. Okay, that's 154 divided by 2, which is 77, I believe. Not negative. There we go. 77. Great. So these angles are both 77. Okay. ICD. Where's I to C to D. All right, that's the one that's not 90 degrees. Well, I know this is 77. I kind of want to say, well, this angle here is half of this arc here. Can I find this arc? Not sure. Oh, you know, I bet I can. I bet I can find it. I can find. Actually, I'm really not sure. Maybe I can't. I would know what KG plus CE has to equal because of the 360 and the 53 and the 101. I know what they add up to, so I could find these angles here. Well, I can find these angles here because they're supplementary to 77. But I can't find out what either one of them is. I was thinking maybe I could figure out this arc here at D and then do a triangle. D would have to be half the difference between CE and 53, but I don't know what that is. You know what I realized? I didn't put this in. Two other pieces of given information here. C to D to I. This is 22. That's what I needed. Okay, great. Now I've got a triangle here with CD. But before I forget, let me also put in this GHF here. GHF. This little angle here is supposed to be 55. Okay. So with the 22 here, I have a 22-77 triangle. I can figure that out there. 22 plus 77 is 99, 180. Okay, so that must be 81. Great. Might as well write it in there. 81. C to G. You know what? I know this JK is coming up. No, I'm not kidding. Actually, would CG be easier? CG might be easier. I know that, okay, the angle inside that thing I just found, that 81, that is half of the arc that it intercepts. So it's from C all the way to G. So from C all the way to G, that's the next thing. That has to be 81 times 2. That has to be 162. Well, if that thing is 162, C, I'll write this way. C to G is all the way around there. Is 162. The last thing I'm looking for is J to K. Oh yeah, that's not really going to help, is it? All right. I could get J to K if I knew J to C because I know KC and I can just subtract. Let me get that other junk out of the way that I just did. Because it's actually not going to be helpful. Okay, J to K is part of J to C. I can get J to C because I have this 31 and this 55. This 55 is supposed to be the arcs it intercepts. Both 55s here intercept a 31 and a thing I don't know. And divide by 2, I'm supposed to get 55. The thing I don't know here I'm talking about is this one. That is what I'm calling X. Okay, that's kind of tricky. X plus 31 then has to be 110. That's a really bad 3 there, sorry. So X is 109, 79. Great. And then what I'm looking for here, just the J to K, that would be 79 minus the 53. So that's 26. Okay. Number 5, circle A, so A is the center. C to E and D to E are tangents. That tells me a lot of stuff like CE has got to be congruent to DE. And the angle, the supplementary thing, arc CD is supplementary to angle E. FG is parallel. to DE. That's interesting. And the arc G to C, this little thing right here, is 47. Is that all the given? Make sure you get all the given. No, it's not. ACE, she keeps saying it this way. That's 90. This one doesn't cause too much problems. I'm just going to go ahead and draw that in. And ADE is 90. Well, of course. Well, look at that. Oh, I've never had that problem before. Interesting. A to D is also 90. And GDE is 45. This is an angle. G to D to E is 45. Interesting. I'll just say this is 45. This angle here is 45. Find FD. Arc FD. Arc from F to D. Well, if this is 90 right here, and this is 45. Yeah, okay, so we have a tangent and we have a chord that it's making an angle with. That means the arc that it intercepts, the arc from G to D, has to be double this thing here. This arc, G to D, has to be 90. And I mean all the way down to D. So if that's 90 and this is a semicircle, I'm left with 90 over here. Oh, we don't have answer blanks. Well, fine. I'll just make my own. All right, F to C. Well, I already knew this is 47. I know this is a semicircle, so I have the rest of 180 here, 143. Sorry, 133. Oh, and then I'm going to have that nice problem. Oh, could I just delete this whole thing? What if I just do that? Oh, progress. Okay, 133. These are degrees. I always said write your degrees. Don't forget these are not lengths. Okay, so this is 133. I hope my arithmetic's all right on this. Angle CHG. CHG. We're looking for this one here. I have a little right triangle here. I know that's 47. I know that's a right angle. This 47 is not part of the triangle, but this 47 is the measure of this central angle here. How do I not select this stuff? All right, this angle then is 47. That's what central angle and arc is all about. So this angle, I should put another thing on. Oh yeah, of course that's going to happen. This angle over here is going to be in a right triangle with a 47 and it. So that would mean it has to be 43. F to G to D. I'd write that in there, but I don't want to accidentally select more stuff. All right, F. Where's F now? F to G to D. Well, if this is 45 here, I know this is 45 here. Yeah, I didn't think that was going to work. Start from over here. Now that's going to just select the other one. Oh, I can start in the middle and go. Okay, so that's also 45. This is 45. We have 45 here. F to G to D. I don't think it's too hard to figure out that this angle over here also has to be 45. I have a lot of, this is 90 here, so this has to be 90 here. I have a 45, 45, 90 triangle. So F to G to D has also got to be 45 degrees. Okay. And angle E, oh, I can probably write that in there. There's not enough stuff written close to that. Angle E, this one out here, we said was supplementary to this guy here, CD. So I can just take 180. This is the trick we learned more recently. 180 minus all of this stuff, which is 90 plus 47, which is 137, is something we found before. It's actually 43. It's the same as CHG. Oh, that's kind of cool. CHG, is that a big? Yeah, I guess that's not surprising because look, CHG and angle E, those are corresponding angles if these are parallel. Yeah, I didn't really have to do any circle stuff to find that one. All right. Great, so you can use that stuff from earlier chapters. It is not illegal. Given circle O, I kind of missed the center point there. Measure for angle TRQ is 30. The measure of arc UT is 53. That's great. And QS is the diameter. Well, of course it's the diameter because we're talking about circle O. Well, I guess we do kind of have to specify that, yes, this point is actually on here. It doesn't really look like it. The measure of arc from T to Q. Oh, you know what? I've only got a few seconds left, so I'm going to stop this now. I'll come back. This will be in part... Ooh, I was going to show you this. This will be in part 3.